So in this video, we're going to be talking about the role of statistics and the data analysis process. So let's start with, what is statistics? Statistics is the science of collecting, analyzing, and drawing conclusions from data. It provides us with methods to help make sense of all the data. So a survey of 100 people asked what fruit was their favorite. When flipping a coin 3 times, what is the probability or what is the chance of getting 3 heads? These are the kinds of questions that interest us and that we can make these conclusions from. So why should somebody study statistics? Well, you need to be informed. Well, what exactly do you need to be informed about? You need to be able to extract information from tables and charts and graphs, because those are things that are brought up in everyday life. You need to be able to follow numerical arguments that people are making. And you need to be able to understand the basis of how data should be gathered, summarized, and analyzed to draw statistical conclusions. There's an old saying that without data, you're just another person with an opinion. So it's important to be able to justify the things that you're talking about. And we do this with data. Think about it. Can dogs help patients with heart failure by reducing stress and anxiety? When people take a vacation, do they really leave work behind? Both of those are questions that were asked and published in the USA Today newspaper from June 29th in 2009. It also took a poll of people, and none of them could name a scientist. So why else should you study statistics? Well, you want to be able to make informed judgments and to evaluate decisions that affect your life. For example, if you choose a particular major, what are the chances of finding a job when you graduate? If you're still in school, what's the best way to fundraise for your club? Should you hold a dance or should you just ask for money? Statistics actually play a very major role in our lives. What is variability? Well, variability is how spread out a group of data is. There are 3 measures of variability that we use: range, variance, and standard deviation, but these are things that we'll talk about a little bit later as well. Now, suppose you went into a convenience store to purchase a soft drink. Does every can on the shelf contain exactly 12 ounces? No, it doesn't. There might be a little bit more or a little bit less in the various cans due to the variability that is inherent in the filling process. Let's think of it another way. Can you imagine how boring the world would be if the entire population did the same thing, liked the same thing, and there was no variance? It'd make it not very interesting to ask people what their favorite color was or their favorite food, because you'd already know, because everyone would have the same. We need to be able to understand variability to be able to collect, describe, analyze, and draw conclusions from the data in a sensible way. Let's look at an example. If the shoe fits. So here we have 2 histograms to the right, and they are distributions of the heights of gymnasts and the distribution of heights of female basketball players. Which one is which and why? Think about it. Our y-axis is the number of people. If we look at our first graph, our figure A, it's varied. Most of the heights are falling between about 68 and 76, right? About 68 and 76. Let's try that again. There we go. And if we look at our second figure, we see that it's varied, with most of the heights in the range between 60 and 72. Although if we were talking about 72, it would come out to about here because of the way the histograms are set up. So if we look at that, which one has more options between their majorities? And we can see that here in our second graph, we have a lot more options than we do here in our first graph. Most people fall between a much smaller range. So which one do you think is the gymnasts, and which one do you think is the basketball players? Figure A is the basketball players, whereas figure B is our gymnasts. Let's try that again. So our gymnastics team. We might also select that our gymnastics team is B, not just because the spread is so varied, but also because if we look, we see that the heights are a little bit smaller and only range up to 74. Whereas basketball players are generally taller, so we would expect to see higher heights for their team. So let's continue with this if the shoe fits example. Suppose you found a pair of size 6 shoes left outside the locker room. Which team would you go to first to find the owner of the shoes, and why? Because you're going to have to make a choice. Are you going to go to the girls basketball team or the girls gymnastics team? I would send them or take them to the girls gymnastics team because usually smaller people have smaller feet and a size 6 shoe is pretty small. Now, suppose a woman who's 5'11" tells you that she is looking for her sister who's practicing in a gym. To which team would you send her and why? I would send her to the basketball team because generally siblings that are the same gender are similar in height. Let's talk about the data analysis process. So it's a 6-step process, and the first step is understanding the nature of the problem. It's important to have a clear direction before you're gathering data. The second step in the process is to decide what to measure and how to measure it. It's important to carefully define the variables to be studied and to develop appropriate methods for determining their values. The next step would be to collect the data. It's important to understand how data is collected because the type of analysis that is appropriate depends on how the data was collected. Our fourth step is to summarize the data and then perform a preliminary analysis of that data. This initial analysis provides insight into important characteristics of the data. Our fifth step is to perform a formal analysis. It's important to select and apply the appropriate inferential statistical methods here. And the sixth step in the data analysis process is to interpret the results. This step often leads to the formulation of new research questions.